everyone. Now we started the second lesson related to data distribution, understanding which kind of analysis we can do, and also to data analysis with a descriptive analysis that give us an idea and give us some useful number, like what is the number of species, how they are distributed in our camera traps, and this kind of analysis that anyway can help to start our thing, what we can do with the data. So now we are here in this folder, which is the folder where I put the script and data to load for this kind of analysis. We get inside data to load, distribution, test, and descriptive analysis. As you see, we have two different scripts. One is the data distribution test, I wrote analysis, but it should be test, and the descriptive analysis scripts. We will use this table that correspond to this one. I changed what we created because this have much more data. It's a table with a lot of data, in this case from African sites, because I had already ready this data. And as you see, I filtered, I removed those data time, data second, data minutes, image number, directory name, and the progressive number, and add one column at the beginning called sampling, because here I did many sampling, 3, 4, called S5, S4, S3, etc. You may have only one, but I still suggest to write it, because maybe you will add some data with the different sampling than same site, so I suggest you add it. What do we mean for sampling? I mean the change of SD. When I go to the field, remove the SD, put a new SD, and take new data. For me, the sampling is start and end with the data collected recorded in a single SD card memory. So the station is this one. In this case, in that side, I wrote GR and 2 numbers, because camera are 30, so 2 numbers were enough. And then the species, we have here many, to check how many. In my case, I have can do filter, and you will see there are many African species, many. So that's it. So I have a reliable data set to make some tests. I left both at the moment, no need to remove both format, date and time, the file name, that's it. So cleaned that matrix, that's it. But remember, do a copy, keep that matrix we produce, the original must be always there, and on the copy you do this work or cleaning that can be done in this case very easy by hand, because you just need to remove columns, so no need to take a headache in R. So once we have this, we can load this one. First, check data distribution to see how the data are distributed. As I told you, you find open with select or right click, open with RStudio. Here we are. Okay, we already did. So here I forgot to put the set D, choose directory. Okay, as you see, the script appear here, and you see we have to load the ggplot2. So install it in the same way. If you don't have, install, write here ggplot2, select, install, wait. Once it's done, go to library here, run. Okay, set 2D. Well, I we'll select this one. Select folder. Okay, that's my working directory. With this tab WD as for working directory. Set the working directory. Okay. Now I load the file I show you. Which is here. Metadata grsamp35. Edit. Okay, this is just incorrect. I don't have any dot, comma, anything. So, column well defined. Now I run a Shapiro work test. Why? To understand if the data are normally distributed. The Shapiro test say the null hypothesis, the data normally distributed if value is over 0.5. So if p-value is under 0.05, we have to reject the null hypothesis. It means that data are skewed, so not normally distributed. Then once we are here, after add the data, we will be here, right, with our cursor, more or less. Yeah. No, what is it? Just a moment. Sometimes are okay. Not okay. Something selected, now it's okay. I have to run and follow the console to understand if I get error, everything goes straight. So run. The first is run, no error. You see here, species count session, okay, fine. Run, print the result, and see. Here give me a p-value of 1.384 minus 0.9. This minus 0.9 means that I have to move the comma 9 times on the left, which means 0.8 before the 1, which means 0 point another 0.81, which is very small p-value, much under 0.05, which means the null hypothesis that the data non distributed is rejected. And we have data that are skewed. You see? Skewed, not normally distributed. So now we can do another thing. Run a QQ plot. Now I will show you explain. Okay, run, print, okay, perfect. Everything is going to be in our folder. In the selected one, is not here, but in the selected folder, working directory, I found, if I go back here, the Shapiro test result, which is here, you see p-value, and this is the result of the test. This means if it's 1, data normally distributed. If we're close to 1, also. In this case, I'm very far, so not normally distributed. Let's see the figure here. QQ plot. It says that, do you see, that are very flat and close, later are very far from the line. This means the data, if on the right of the theoretical quantiles, means the data are skewed, very skewed in this case. Not only, it means that there is a few sites where there are a lot of species and animal, and other have less species and animal. And the most of the other have few species and animal. So we can conclude with this kind of result. Going back to our explanation. The species total by session are not normally distributed. There are some outliers, which probably is waterhole, in this case, this water spring, contributed to the skewness. non-parametric statistical, likely more appropriate for this data. So don't use ANOVA. ANOVA cannot use for that because data are not normally distributed, but you can use Kruskal-Wallis test, Mann-Whitney-U test, or sperm correlation. So, of course, this is on a large data set, very heterogeneous. Then we have to check better the data. But anyway, in our subset of data set we choose, we can still do this analysis, though the subset of the data set at the beginning, see if our data are normally distributed according to the analysis we need to do. So that's already another important step. See you for the second part of this lesson.